We learned about light rays and laws of reflection and mirror images in the two previous lessons on light. This is the third one on light, and we'll talk about the most important sense organ we have, our eyes. This is what an eyeball looks like from the outside. If we cut it, this is what it looks like. This would be called a sectional view of the eyeball. The front part is called the cornea, which is transparent and it bulges out a little bit. And this makes our eyeball not perfectly spherical. The next part is called the iris. And the part behind the iris is the eye lens. The space between the cornea and the eye lens is filled with the liquid called aqueous humor. The cornea shapes the aqueous humor into a convergent lens to get the rays of light onto the lens. The iris gives the eye the color that we talk about when we say that someone's eye is brown or blue or green, and it is the iris that controls the amount of light that goes into the lens, and the hole that it leaves in the center for the light to go in is called the pupil. In humans, the pupil is round and it gets smaller when we step out in the bright sunlight, because then we need less light entering our eyes, and this same pupil becomes much larger if we are trying to look around in the dark. When the rays of light go through the pupil onto the lens, now the lens has to make sure that it bends the rays so that they converge exactly on the retina so that it gives a sharp image. The retina is the inside layer of the eye, which is like a screen on which the image is formed. To make this image sharp, the lens has to adjust its focal length depending on how far the object is. If the object is close, then the focal length has to be small. And if the object is far, then the focal length needs to be large. And this change of focal length is done by changing the shape of the convex eye lens itself. And it is possible only because the lens itself is made of transparent, living jelly-like tissue that is stretched and pushed by a special group of muscles called the ciliary muscles, shown as the red strands in this model. Here you can see, perhaps for the first time ever in a live model, that the lens actually changes its shape, and you can see the light beam move according to the change in focal length. The entire space between the eye lens and the retina is filled with another liquid called vitreous humor. Once the image falls on the retina, it processes the image, and the retina is connected to the optic nerve, which takes the information of the image in the form of electrical signals to the brain. Accessories to the eyes. And then we also have the eyelids, tear glands, as well as the eyebrows that also serve a function towards the eyeball as such. The eyelids protect the eyes, and you will see that instinctively we always shut our eyelids the moment we think anything is about to hit our eyes, or even our face for that matter. The eyelids also serve as a cleaning mechanism like the windshield wiper in a car. This is because dust keeps settling on the wet eyeball and the eyelids keep cleaning it off every time they blink. The tear glands also help in keeping the eyeball moist so that the eyelids can glide easily. This too has been copied by car makers, and that's why you have a spray lever to wet the windshield before you use it. Otherwise the dust can scratch the glass in a car, and in the same way your eyelids could scratch your eyes if they are not moist. The eyebrow itself just helps reduce any sweat or dust from trickling in down into the eyes from the forehead. So that was a lot of information about the eye and its parts and the other parts that also serve the eye. Now let's see how the images are formed on the retina. Image on the retina. The rays of light from the object, say a tree, reach the cornea. They are first converged here towards the eye lens. At the eye lens, they are then focused to meet at a point on the retina. The rays from the top of the tree will converge from the lens to the lower side of the retina, and the rays from the bottom will converge at the higher side of the retina. Therefore, the image formed on the retina is inverted. But then our brain corrects it, and therefore we don't see an inverted image but an upright one. Once again, the iris controls the amount of light coming into the eyes through the pupils by adjusting the size of the pupil or the hole depending on the amount of light outside the eye. It also takes time to adjust the sight when we suddenly move from brightly lit places to dark places, or from dark places to brightly lit places. Rods and cones. Inside the retina, there are light sensitive photoreceptive cells that receive the image. Photoreceptive means that they can receive and process photos or images in this case, that come into the retina, and these are of two types, rods and cones. Rods are called because they are rod-shaped cells that are responsible for vision in low light situations. So in dim light or in the night, rods are relied upon by the retina. Cones are used for normal light as well as for the sensation of color. Rods cannot process color, while cones cannot work in dim light. Blind spot. Only at one point, that is the junction of the retina and the optic nerve, there is a blind spot in the eye and there is no image formation there. There's a very easy way to find the blind spot. Try this experiment if you're watching this on a phone or a tab. I'll put a plus and a dot on the screen. So you can pause the video at this frame. You can see that the plus is on the left side and the dot is on the right side. Now you hold it in front of you like this, full arm's length. Shut your left eye and look with only the right, and look at the left side, which is the plus side. Notice what is happening to the dot, but at the same time keep looking at only the plus side and slowly keep bringing it close to you. What will happen is at one point here, at one point the dot will disappear, and that is the blind spot. And you can do the same thing with the other eye, where you shut your right eye and with your left eye, this time you look on the right side, which means that you are looking only at the dot. Notice the plus, but look at the dot, and once again keep bringing it closer. Yeah, at one point the plus has totally disappeared, and that's the blind spot in my left eye. Persistence of vision is the optical illusion of seeing an image after the object has been removed from the sight and its rays are no longer coming into the eyes. These images stay on or persist for around 1/16th of a second even after the object has disappeared from our sight. So pause the video at this plus and stare at it for some time, and then you shut your eyes and you'll still be able to see the plus for a little while. That's an example of persistence of vision. This is also the reason why we never notice our eyelids blinking throughout the day, while it actually does that about 15 to 20 times every minute. That is more than 20,000 times in the day. All movies, video, animation, every moving image that we see is actually made up of single photos, and they are in sequence if you stop it and look at them. But if they run at 16 pictures or 16 frames per second, then we get a sensation of moving pictures. To make the movement smooth, the ideal number of frames per second that are used in the movies and videos are 24 frames per second, like it was in this kicking sequence. But now in the same sequence, I will keep decreasing the speed till you can start seeing single frames. So you can now see that each frame as such is like a single photograph. And as we run them, we can see individual images in sequence while moving forward. And we can even make the images run in reverse sequence as if the person is going backwards, frame by frame. And if I increase it to much more than 24 frames a second, then you can see an effect that is like fast forwarding. The simplest way to check out persistence of vision is this experiment, where you can take a small card like this and draw a simple figure of a man or a monkey with his hands down. On the other side, exactly behind it, which you can do by holding it against light. And now draw the same thing but with the hands in the air. Fill up this drawing as a thick line, or you could even use a thicker pen to begin with. Now cut a straw as shown, and then slide the card inside it. Rotate the straw between your hands and you will be able to see the image animating as if the monkey is moving his hands. Same thing you could do with a bird sitting in a window. And note that it's not a cage, because it's cruel to put birds in cages. To make a more elaborate set of images, you can also draw in the corner of all the pages of an old book. Draw with pencils so that you can erase it later if you need to. The range of vision of the human eye. The human eye has a range of vision that is between the farthest point it can see, that is called far point, and the nearest point it can see without too much strain, and that is called the near point. The far point of the eye is infinity. That's why we can even see the moon and the sun and the stars. The near point is limited to about 25 centimeters. When you look at close by objects, the divergent rays from the object have to converge more to reach the retina. So because of that, the eye lens has to become thicker and the ciliary muscles are more stressed to hold the lens in that form. When you look at far away things, the rays coming from the objects are almost parallel, and therefore the eye lens remains thinner and the ciliary muscles are more relaxed. So that's why when you read a book or stare at any screen for a length of time, it should not be closer than 25 centimeters from your eyes. And even then, you should keep looking up every few minutes and relax your eyes by looking at something far away. And apparently, looking at the color green is more relaxing than looking at most other colors. The defects of the eyes. Apart from total or partial blindness, there are three main defects of the eyes that one comes across: myopia, hypermetropia, and cataract. Myopia is a defect in the eyes causing an issue of sight where a person cannot clearly see the objects that are far away, even though they have no issues seeing objects clearly that are close by, or even when they read. This is what happens. The rays converge before the retina and therefore the image is not sharp, it's blurry. Concave lenses are used to correct myopia. Hypermetropia is the opposite, and I used to remember it as the hyper one. Here the person cannot see things which are close by, like reading becomes difficult, but people with hypermetropia can see far away things like normal people do. This is what happens in hypermetropia. The rays converge beyond the retina. Convex lenses are used to correct hypermetropia. Cataract is a different kind of medical condition where the eye lens of a person or even an animal gradually becomes cloudy and results in blurred vision and can eventually lead to a total loss of vision as well. I have these two polythene bags, and with these I'm going to give you a feel of how a person with cataract sees. So the vision starts becoming cloudy. That's level 1, but you can still see. But slowly over time, the cloudiness becomes so much that you can't see much except for silhouettes. It mostly happens with old age and cannot be corrected by spectacles, but it requires a surgery where they remove the lens that is getting clouded and put an artificial lens in place. Taking care of our eyes. Eyes are the most important sense organs and you must take care of them, and there's not too much that you actually need to do about it. Wash your eyes at least twice a day with clean water. Too bright or too dark environments will strain your eyes. Never look at bright flashing lights directly, and this includes sun, car headlights, welding and other such things. When reading or using a screen device like phone, maintain optimum distance of about 25 to 30 centimeters and keep looking away into the distance frequently. If some dust particle enters your eye, ask someone to blow in your eye or wash it with clean water. Do not rub it as much as possible and visit the doctor if the irritation doesn't go away. If you find your vision getting blurry at any time, make sure you check your vision at a doctor. Vitamin A is important for good health of the eyes. It comes from foods like carrots, green vegetables, cod liver oil, eggs, milk, butter, etc. Lack of vitamin A can cause ailments of the eye like night blindness, where a person finds it difficult to see properly after sunset, while in the same conditions, others might find it normal to look around. Animal eyes. Let's learn a little bit about the eyes of some other animals as well. Cats are supposed to be able to see in the dark, but actually they can only see a little better than us in the dark, but that doesn't mean they can see in total darkness. It's just that cats and other nocturnal animals like owls have more rods in the retina and they have exceptionally large pupils that allows a lot more light into their eyes. And both these things help them see better than us or the other day animals. Many animals like crabs have protruding eyes that allow them to see almost 360 degrees all around them. Our field of view is 210 degrees horizontally, like this, and 160 degrees vertically, means from here to here. Eyes of many insects are made up of many segments, like the eyes of a bee or a fly, and these kind of eyes are called compound eyes. The honeybees have 5 eyes actually, 2 big eyes that we easily notice, and there are 3 smaller ones on the head as well. It is said that bees might be seeing the world something like this. Now a question, why do we need 2 eyes? In fact, humans and most animals have 2 eyes. Why? The answer lies in this simple experiment. Take 2 pencils or pens, hold them in front of you with the arms bent a little, and now shut one eye and bring them together so that they touch each other. But try it in one go. at this speed. You will see how difficult it is to join them. Now do it with both eyes open. It becomes so much easier. Now do you have the answer? Two eyes help us get a sensation of depth which one eye cannot give. So that's how we can judge distances and how far objects are from us. There are people who are born with no sight and they are blind. This can also happen due to a medical condition later in life, but also due to accidents. These people are said to be visually challenged. To gain information and operate in the world like normal people do, they need to increase their dependency on other senses like touch, smell, taste, and hearing. For written communication, Braille was created. Braille was developed by Louis Braille from France. Braille invented a system of matrix of 6 dots where one or more dots will be raised to denote an alphabet or a number, and this was found much easier to read through the sensation of touch. Now even currency notes are supposed to have the denominations written in Braille. Being visually challenged did not stop many people from becoming great personalities through their work. Helen Keller from the US was 18 months old when she lost her sight, but she went on to become a graduate and write famous books like The Story of My Life. Similarly, Ravindra Jain from India obtained the Sangeet Prabhakar degree from the Allahabad University and went on to become a famous lyricist, singer and a music composer. Now let's do a recap and move on to the TIY project. Parts of the eyes and the functions. The front part of the eye is called the cornea. The next part is called the iris, and that gives color to the eye, and it controls the amount of light going into the eye. The hole in the iris through which the light goes into the eye is called the pupil. The eye lens is behind the iris. The eye lens focuses the rays of light on the retina to give a sharp image. The eye lens can change its focal length by changing its shape. The eye lens is controlled by a group of muscles called the ciliary muscles. The retina processes the image using rods and cones and is connected to the optic nerve, which takes the information to the brain in the form of electrical signals. Image on the retina. There are two types of photoreceptive cells in the retina: rods and cones. Rods are responsible for vision in low light situations. Cones are used for normal light as well as for the sensation of color. At the junction of the retina and the optic nerve, there is a blind spot where there is no image formation. Persistence of vision is the optical illusion of seeing an image even after the object has been removed from sight and its rays are no longer coming into the eyes. The range of vision of the human eye is between 25 centimeters and infinity. Defects of the eyes. Myopia is the defect in the eyes causing an issue of sight where a person cannot clearly see objects that are far away. Hypermetropia is the condition where the person cannot clearly see close by things. Cataract is the medical condition where the eye lens of a person gradually becomes cloudy and can eventually lead to a total loss of vision as well. General. Eyelids, tear glands and eyebrows also have their roles towards the eyes. We learned about some steps for taking care of the eyes. Some animals have different types of eyes and different power of vision as well. We also saw why two eyes are better than one. Blind people can read using Braille through their sense of touch. In this DIY project, I will show you how to make a simple animation or moving pictures using still pictures. This type of animation is called stop motion animation, where we use objects instead of drawings. And this way anyone can make an animation. The first thing we need is a camera or a mobile phone to shoot the pictures. And if you can get one in which you can do a focus and exposure lock, then it will be best. Exposure lock in different cameras is done differently, and in mine it is done by choosing the frame that you want to shoot and then pressing it in the main area where the action will be. In this case, the center is best, and then it locks. Now when my hand comes in front of it, the camera doesn't try to adjust its exposure or focus. If it wasn't locked, then see what would have happened. The shots keep becoming brighter and darker because the camera tries to adjust its exposure depending on what it sees. If you don't have an exposure lock, then you have to do things very slowly so that you let the camera adjust after every movement. Next, you need a stand. If you have a tripod, then it's best, but otherwise let me show you how to make a tall stand to keep on the table using a regular type of plastic container. We need two small wooden blocks that will hold the phone in place on the top. This is how the phone needs to be kept so that the camera looks over the top. To hold these blocks, you can glue it or stick them using a double-sided tape. Let the tape be a little extra long, it doesn't matter. Peel it and stick the first block of wood at the edge of the cap. Now put the camera on before fixing the phone angle so that you can see what is coming in the frame. It is important to let a bit of the phone stick on the tape as well. The other block of wood will hold it in place. Now you can see that the angle is set to look at the table. Now you need to stick tape on the table, or you can use chalk so that you know the exact parts of the frame that are coming in the photographs. These borders of the frame should be just outside the visibility of the phone camera. The advantage of making this frame is that if you want to be on the other side of the camera, then you can animate the objects while a friend could be clicking the pictures. Here's a warning, make sure that you ask for permission to do all that with the phone, especially if it's not yours. And anyway, be extra cautious with expensive devices like mobile phones. Because the phone is at an angle to the table, the frame is not a rectangle but an isosceles trapezoid. That's it. Take some object like a small toy and start moving it frame by frame and shoot each picture. In each frame, the object should move very little depending on where it was before and where it is headed. And remember, this is the simplest way to animate something, and therefore it is very basic. Actual animation has its own science where you need to calculate the number of frames that you need to shoot for various types of movement so that it's close to real life movements. In this type of animation, you will see that the movements are jerky, but the animation is anyway fun to do. Now you can bring in some more objects and keep relating them to each other. It is important to know that we are only learning how to animate objects, but an actual animation will first start with the story that you want to tell. And that's most important. This one is not a story, but you can think of it as a moment in the life of rock, paper, scissors. See how the paper was crushed in stages. And after you've shot all the photos, you will need to edit it and put it together. For that, you can download any app and use these pictures and put even sound and music to it. I won't get into that now, but I will share a different video on the channel later to understand how to put them on an app to make a video. But I'm sure you can figure out apps yourself. Okay, let's see how it turns out with some basic sound added to it. Things required for the DIY project: plastic container, wooden block, 2 pieces, double-sided foam tape or a glue gun, mobile phone, insulation tape or chalk, a small stone, a sheet of paper, colored paper will be better, scissors. So now that you've learned how to give life to your toys, have some more fun with it. But keep in mind there's so much more to see in this world and even beyond this world. So join me in the next lesson, which is on stars and the solar system.